Today, I would like to teach you how to find the percent compositions of each of the elements inside of ammonium carbonate. First thing is we got to find the mass, then we can find those percents. Watch how easy as pie this is. Bam! So the first thing is we're going to write the elements down that we see. So we got nitrogen, we got hydrogen, we got carbon, and oxygen. Then we're going to write the number of atoms of each, and that's where the subscripts come into play. Now, if you don't see a subscript at the bottom of an element, simply write in a 1 there, because that's what it is assumed to be. Now, the total number of atoms for nitrogen is not 1 because you have 1 nitrogen in the ammonium polyatomic anion. You have, though, 2 ammoniums, and therefore you'd have 2 nitrogens. In other words, simply take the inner subscript, multiply it by the outer subscript there to find the total. Okay, so you got 2 nitrogens. Same thing for hydrogen. Hydrogen has a subscript of 4, but it also has an outer subscript of 2, so you multiply them together, so there's a total of 8 hydrogens. Carbon has a 1, subscript of 1, so that's all, and oxygen is 3. Then we're simply going to take those number of atoms and multiply by the mass of each element. That's where the periodic table comes into play. So hydrogen's mass is 1.01, carbon is 12.01, nitrogen is 14.01, and oxygen is 16. So those are the masses we're going to write down. So 14.01 for nitrogen, hydrogen was 1.01, carbon was 12.01, and oxygen was 16. I don't even know what kind of a number that is. Okay, there we go. All right, and then to find the total mass of the element in the compound, we're simply going to multiply the row on across. So the total mass here of nitrogen is going to be 28.02. The total mass of hydrogen is then 8.08. The total mass of carbon is then 12.01. And the total mass of oxygen is going to be 48. And that's a 14. 48. Okay. And then to find finally the total mass of the entire compound, all you got to simply do is add this column on up. All right, so 96.11, that's the total mass. And there you have it, right? That was the first step of the process, finding the total mass of the compound. Now that we have the total mass in hand, I'm going to add a column to the table to find those percentages. Watch how nice and simple this is. Bam, so to find the mass percent of, let's say, nitrogen, we're going to take the total mass of nitrogen here. We're going to take the 28.02, and then we're going to divide it by the total mass of the entire compound, the 96.11. And then multiply it by 100. That is a simple percent calculation. Part over whole times 100. That's how that table helps. It gives us beautiful structure. Now all we need is just to look at this column. So when we do the math there, it works out to be 29.15%. So that's the percent composition or mass percent of nitrogen. Same thing for hydrogen. Take the total mass of the hydrogen there, 8.08, divided by the total mass of the entire compound, multiply that by 100, and you get a mass percent here for hydrogen of roughly 8.41%. All right. And then carbon, I think you're identifying the pattern by now, right? Just move on down. That's how the table kind of really helps. It gives us beautiful structure to follow and makes it nice and easy. And then oxygen, same thing, 48. I'm going to leave out the zeros, but careful. Don't leave them out in your calculation of sig figs. I won't mind, but your professor might. 49.94%. And then just to check yourself here, you can always add these up, and it should equal 100%. You know, you're rounded, so it might be a little off, like 100th, but it should be there, all right? And that's all there is to it. Now you know how to find the mass percents of every single element inside of ammonium carbonate. And by the way, this process is not exclusive to ammonium carbonate. You can use this process on any problem you like that you need to solve mass percent for of any compound. Thanks for watching.